Hey guys, it's Miss Johnson, and I'm back to finish off our Unit 2 Notes 4 lesson with the second part of our notes video for today. We have 4 word problems on the back of your notes sheet that we're going to look at now. These are word problems that are all related to systems. We're going to have to write equations for these, and we're also going to have to solve those equations. So now that we've got a couple of different tools in order to solve systems, we can actually tackle some word problems like this. So taking a look at number 7, it says campus rentals rents 2 and 3 bedroom apartments for $709 per month respectively. Last month they had 6 vacant apartments and reported $4,600 in lost rent. How many 2 bedroom and 3 bedroom apartments were vacant? So, first thing that I always say to do in word problems, the first thing that you need to do is figure out what are you being asked. How many 2 bedroom and 3 bedroom apartments were vacant? So that's what I'm going to name my variables. I'm going to say that X is the 2 bedroom and that Y is the 3 bedroom. That could just be a colon, but anyways, you get it. So X is my 2 bedroom, Y is my 3 bedroom apartments. Now, I need to go back and look at to the beginning and look at what's happening with these variables. So I know that 2 bedroom apartments are $700. I know that 3 bedroom apartments are $900. And I know that they lost $4,600 in rent. Okay, so I can make one equation with the money that has to do with this whole situation. I can say that there's $700 times every X plus $900 times every Y. $700 for 2 bedroom, $900 for 3 bedroom. And all together, they totaled $4,600 loss in rent. So is equal to 4,600. The other piece that I'm told is that there are 6 vacant apartments. So if I just look at the sheer number of apartments, that's X plus Y is equal to 6. Some are 2 bedroom, some are 3 bedroom, total of 6 vacant apartments. All right, that is my system. Now I need to solve it. Okay, so I am going to work to get a variable alone here, okay? Now that you know these 2 different methods of solving, you can make a choice. You can either multiply this bottom equation so that it has an opposite coefficient with the top, just like we did all in elimination, and that would work. Or you can move one of these bottom variables over so that you have a variable alone and use substitution. That would work as well. Both ways require a little bit of manipulation before you can get started, so I don't think it's really going to make a difference for us. I'm just going to go ahead and subtract this y variable in the bottom so that I have x is equal to 6 minus y. And then, or negative y plus 6, you could have written it like that. I'm going to take this 6 minus y and I'm going to plug it in for x right there. So I have 700, because I know that it's equal to x. 700 times 6 minus y is equal to 9, I'm sorry, I forgot, forgot the rest of that, plus 900y. There we go, is equal to 4,600. All right, so distribute your 700. 700 times 6 is 40,200 minus 700y plus 900y is equal to 4,600. And then I can put my 2 y terms together. Negative 700 plus 900 is positive 200. So 4,200 plus 200y is equal to 4,600. So then once we are there, I'm going to subtract the 4,200. So I have 200y is equal to 400. And then divide that by 200. And I get y equals 2. So I know that there were 2 3-bedroom apartments that were vacant. I need to plug that back in and get the other one. I know that one of those equations was x plus y equals 6. So I'm just going to take my 2 and plug it in there. X plus 2 equals 6 and subtract your 2. X equals 4. So I end up with a solution, and remember that every question that has words needs an answer with words. So I've got to label these. I've got to say what I'm talking about here. There were 4 2-bedroom apartments and 2 3-bedroom apartments. All right, so let's take a look at number 8. In number 8, it says the larger of 2 numbers is 8, more than 4 times the smaller. If the larger is increased by 4 times the smaller, the result is 40. Find the numbers. Holy buckets. So the larger of 2 numbers. I know I'm looking for 2 numbers here. So I'm going to call x my first number, and I'm going to call y my second number. I just know that I need to have a variable for 2 different numbers. Now I go back to the beginning and figure out what's happening with these. So the larger of 2 numbers is, that word is, if you think back to Unit 1, tells us is an equal sign. 8 more tells us we're adding 8. So 8 plus. Then 4 times, which is 4 multiplied by the smaller, which I was told is x. Okay, first, second, you could also call this smaller, larger. Okay, doesn't really matter. You just need two variables. Okay, so there's my equation. The larger was the y. So my first equation looks like y equals 8 plus 4 times x. All right, second equation. If the larger is increased by 4 times the smaller, holy buckets. If the larger is increased by 4 times the smaller, so larger is increased by 4 times the smaller. Increased by kind of implies that we're adding. So I've got y plus 4 times the smaller, which is x. The result is 40. So equals 40. All right, there's my system. There it is. Now I got to solve it. I recognize right away that I've got a y equals, so I know I can take this 8 plus 4x and plug it in for y right down there. And I'm going to be able to solve it using substitution very easily in this case without any steps that I have to do beforehand. So I have 8 plus 4x. Remember, this is now gone because I'm replacing it with the 8 plus 4x. Plus another 4x is equal to 40. That's 8 plus 8x, putting those like terms together, equals 40. Subtract your 8. I have, 8x. Oh my goodness, my pen is so lagged. Sorry. 8x equals 40 minus 8, which is 32, and divide by 8. X is equal to 4. So now, when I go back up and plug it back in, I know that I've got that equation on the top where it says y is equal to 8 plus 4x. So I'm going to call that 8 plus 4 times 4 because my x value is 4. So 8 plus 16, which is 24. So my two numbers are 4 and 24. All right. Let's take a look at the next one. The State Fair is a popular field trip destination. This year, the senior class at Apple Valley High School and the senior class at Eastview High School both planned trips there. Senior class at Apple Valley rented 8 vans and 8 buses with 240 students. Eastview High School rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students as did the buses. Find the number of students in each van and each bus. So right away I know I need to look for what I'm trying to find. Find the number of students in each van and each bus. So I'm going to say that X is my vans and Y is my bus or buses. All right, so I have 2 equations. I'm going to have one equation for Apple Valley And I'm going to have one equation for Eastview. If I take a look at Apple Valley, it says the senior class at Apple Valley rented and filled 8 vans and 8 buses with 240 students. So I have 8 times x plus 8 times y is equal to 240. Then Eastview rented and filled 4 vans and 1 bus. So for my Eastview equation, I have 4 times every van plus 1 times each bus is equal to 54 students. All right, that's my system. Now I got to solve. So you have a couple of choices. You have x's, y's, and equal signs and constants lined up here. So if you wanted to get opposite coefficients and solve that way, you could. Or I also recognize that in that bottom equation, I have that y variable by itself. So I can very easily subtract the 4x to the other side, and I'd have y is equal to negative 4x plus 54, and I can solve it like that. So I'm going to solve using substitution by moving that 4x over to the other side. Now this whole expression right there is equal to y. I'm going to plug it in for y in my other equation. Don't forget, you're just replacing the y. Keep the 8 that's in front. So I have 8x plus 8 times that whole expression. Negative 4x plus 54 is equal to 240. And then when I distribute that 8x is equal to, oops, sorry, plus, is what I meant to put, plus, there we go, negative 32x, because 8 times 4, negative 4 is negative 32, and then plus 8 times 54, which gives me 432. 432. That was a 54, by the way, in case that looked like a 34, it was 54. 432 is equal to 240. Now the system is getting kind of funny because when I put these together, 8 minus 32 is negative 24x. So I've got like a negative x value here, which is interesting, but I'll show you what happens. Plus the 432, because you're kind of thinking, I can't have a negative number of buses. That doesn't make any sense. But take a look at what happens. When I subtract the 432, I'm going to have a negative constant over here, and then I'll divide a negative by a negative and get a positive, and it'll all be good. So 240 minus 432 is negative 192. And then divide by the negative 24, and you get x is equal to 8. There's that negative divided by a negative, which gives me a positive. So x equals 8. I'm going to go back up to this equation right here, where I have y equals negative 4x plus 54, and I'm going to solve for y. So y equals negative 4 times 8 plus 54, and that's y equals negative 32 plus 54, or y equals 22. So that tells me that each van, remember I need to label my answer, each van holds 8 students, or 8 people, and each bus holds 22 students. All right. One last word problem that we're going to look at together. Brenda's school is selling tickets to Spring Musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. School took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What's the price of 1 senior citizen ticket and 1 child ticket? So that's what I'm trying to find. That's what I need to name variables for. So I'm going to say that X is my senior citizen ticket, and Y is my child ticket. All right, so now I go back to the beginning, write the system. On the first day of ticket sales, the school sold 3 senior citizen and 9 child tickets for a total, which is like your equal sign, of $75. So 3 times X plus 9 times Y equals $75. Second day, $67 by 8 senior citizen and 5 child. So 8 senior citizen, 5 child is equal to $67. All right, there's the system that I need to solve. Now, when I look at this system, I've got choices. We know we can graph, we know we can use elimination, we know we can use substitution. Graphing would be ugly because I've got a lot of work that I have to do just to be able to graph them. Um, I think substitution here actually seems ugly because I don't have a variable alone and I don't even have a 1 coefficient anywhere. So I'm actually going to choose to use elimination for this question because I have my x's lined up, y's lined up, equal signs lined up, and constants lined up. I still have a lot of work to do because I don't have any opposite coefficients, so I need to multiply both of these equations. So I'm going to take this top equation and I'm going to multiply it by 8, and I'm going to take this bottom equation and I'm going to multiply it by -3 because that's going to give me a 24x, that's going to give me a negative 24x. Those will drop out after I combine them. So 8 times 3, remember that this needs to go all the way across to all 3 parts. So I have 24x plus 72y is equal to 75 times 8, which is 600. And then on the bottom, -3, so -24x minus now, because negative times positive, minus 15y is equal to 67 times 3, which is 201. Oops, 201. Now I can combine these. And when I do that, my x terms drop out, and I'm left with 72 minus 15, that's 62, that's 57, I think. 72 minus 15, let me just check. Yep, 57. You can always check these things working on your calculator. So 57y is equal to 600 plus, oh, and I almost forgot, hello, that should be a negative 201. Sorry about that. -3 times 67 is a negative 201. So 600 minus 200 would be 400, but I'm taking one more away, so 399 is what I'm looking at. Divide those by 57. It looks like a really ugly thing, but I actually think it works out to be a whole number. So 399 divided by 57. And look at that, I get 7. So y is equal to 7. Now I need to go back to one of my original equations and plug it back in. I'm just going to use the top one. Doesn't matter which one you pick. So I have 3x plus 9 times 7 is equal to 75. That's 3x plus 63 is equal to 75. Subtract your 63 and you get 3x equals 12, and divide by 3 and you get x equals 4. So I know now if I summarize this solution, X was my senior citizen tickets. So senior tickets are $4. And Y was my child price, or my child tickets. Children's tickets are $7. That senior discount, that's really beneficial there. All right, that takes us to the end of our Unit 2, Notes 4, Solving Systems Using Substitution. So thanks for listening, and don't forget to check your note sheet off with Ms. Johnson, and I'll see you later.